This is the solution to problem 6 from the Triangle Trig applications notes. We're told that in kite, K-I-T-E, Ki is equal to Ke, which is 10, and that's been labeled on our diagram here. And that It is equal to Et, those are both 7 units. And we're told that the measure of angle IKE is 40 degrees, and we're asked to find the degree measure of angle ITE. So the angle that we need to find is over here. I'll call it theta for now. So we need to find theta. So one thing that we can do is perhaps we can take this kite and divide it into two triangles, since we know law of sines and cosines. Perhaps they might help. So I am going to draw in segment EI, and the reason I'm drawing that segment is because we know angle K is 40 degrees, and now I can create a triangle KEI, and I can use that triangle to find the length of EI, which I'll call little k. And if I know the length of EI, which is little k, I can go from the left triangle to the right triangle and then eventually get angle theta. So looking at the left triangle, so I have triangle IKE. I can see that I know side, angle, side. So this is side, angle, side. And with side, angle, side, we can use the law of cosines. So I can use the law of cosines to find the side length k. So remember, law of cosines is c squared is equal to a squared plus b squared minus 2ab cosine c. It's a modified Pythagorean theorem. So here, instead of c, we're going to use k. So k squared is equal to a squared and b squared are both 10 here. So 10 squared plus 10 squared minus 2 times 10 times 10 times cosine of k. In this case we need, and k is 40 degrees. And if you enter all that in your calculator, 10 squared plus 10 squared is 200. 2 times 10 times 10 is also 200. So minus 200 cosine 40 degrees. And if you take 200 and you subtract 200 cosine 40, you will get 46.7911 dot dot dot. Leave that value in your calculator and then take the square root of both sides, and we'll find that k is 6.84 units. I'm going to go ahead and write that on our diagram. So 6.84 units. And now we'd like to find theta, which is angle T. So let's go ahead and let's look at the second triangle, the triangle on the right. So I'm going to focus now on the triangle on the right, which is, I'm going to focus on triangle IET. And for this triangle, we actually know all three side lengths. So this is a side, side, side case, which means we can use law of cosines again to find the missing angle, which would be the measure of angle T, or theta. In the previous part of this problem, we used law of cosines to find a missing side length. So we're going to use law of cosines. So we're going to have 6.84 squared is equal to 7 squared plus 7 squared minus 2 times 7 times cosine of t. And if we put things in our calculator, the left side becomes 46.7911. That's the value that we had over here, right? Because we found the square root of that to get k. That's going to be equal to 7 squared plus 7 squared is 49 plus 49, which is 98. 2 times 7 is also 98. So minus 98 cosine t. Subtracting 98 from both sides of the equation, we'll get minus 51.208 is equal to minus or negative 98 cosine t. To isolate cosine t, divide both sides by negative 98. So cosine t is equal to negative 51.208 over negative 98. And if you enter those values in your calculator, you'll find out that they're about 0.5225 dot dot dot. So t is going to be cosine inverse 0.5225 dot dot dot. Just leave that value in your calculator. and you will find that t is equal to 58.5 degrees. So in this problem, we drew in segment EI, creating two triangles, and we used law of cosines twice, using the triangle on the left to find the side length k, the triangle on the right to find the angle opposite it.